For pretty quite a while, individuals had been enchanted by the charming region of mechanical skill, looking on the evening sky and analyzing the mysteries safeguarded inside the stars. From the start of human headway to the ongoing, our side interest inside the universe has least difficult increased. At the front of room clinical perceptions stands the James Webb Space Telescope, analyzed in light of the fact that the world's most helpful observatory. This remarkable telescope not just reveals insight at the secrets of our close BIP planetary organization, yet in addition leaves on a significant experience investigating the beginnings of the universe and distant universes surrounding different stars. In sync with the prominent astrophysicist Neil deGrasse Tyson, the James Webb Space Telescope, well known, shows natural parts of our universe in another light, permitting us to examine the far-off past. In its presentation year of activity, the James Webb Space Telescope has presented a staggering exhibit of pictures, checking easiest the start of its most memorable rate commitments. Tyson accentuates the telescope's remarkable plan, particularly expected to catch infrared gentle. This is significant on the grounds that, as Tyson makes sense of, Earth-based instruments can't gather excellent data from the early universe because of a gap in our customizable spacetime continuum. The focal point on infrared light is fundamental on the grounds that all through the start of stars and cosmic systems, bright light is radiated. Over the long run, these gentle waves stretch into extra frequencies as they go, extending region, and in the long run, transforming into infrared when they achieve us. The telescope's perceptions have figured out cosmic systems shaped billions of years previously, conferring bits of knowledge into our planetary structures. Planets, from a pristine point of view, Tyson tends to the temporary mission, gave by means of gazing at divine things that produce gentle a great many or billions of years in the past. He utilizes an exhilarating relationship, bringing up that even in the event that you have been in the equivalent room, the gentle accomplishing us from nearby items is a picture of their past, similar as seeing somebody as they had been a couple of moments in the past. Specific telescopes permit space experts to view stars that detonated parcels or a long period of time in the past, essentially portraying them as of late detonated. The stars and planets apparent in our evening time sky are apparitions in their past selves, existing or presently not inside the gift. Tyson dives into the beguiling relations made via the James Webb Space Telescope, for example, catching the early stages of heavenly nurseries, uncovering baby stars, and the development of planets. One such discourse comprises of the heavenly nursery, approximately 390 light-years away, giving a unique vantage variable to seeing the planetary group's initial stages. The telescope furthermore investigates the dusty circles encompassing more youthful stars, like our sun's initial days, and unwinds the circumstances fundamental for life's beginning spot in heavenly nurseries. In a hypnotizing experience through the universe, the James Webb Space Telescope's photographs exhibit the coronary heart of the Crab Cloud, offering a more top-to-bottom glance at a neutron star's remainders from a cosmic explosion blast in 1054. The photographs uncover the dynamic interaction of strong attractive fields, following in ethereal white streaks, a scene made through exorbitant speed electrons, as the telescope unravels the secrets of region objects like Copia, a cosmic explosion remainder. New sections unfurl in our data. The Copia cosmic explosion remainder, enlightened via the James Webb Space Telescope, takes center stage, conferring a top-to-bottom perspective on its detonating shell and shedding gentle on newfound designs. In praising the Christmas season, the James Webb Space Telescope catches the excellence of Copia, compared to an incredible trimming. This close-up is made feasible by means of the telescope's close-to-infrared computerized camera. Notable shows elaborate data of the star's blast and its association with surrounding gas. With each picture, the James Webb Space Telescope lifts our data of the universe, offering a noticeable account that rises above the limits of region and time. As we dig into the universe, directed by utilizing the disclosures of this outstanding telescope, the marvels of the universe unfurl, welcoming us to consider the vast secrets that lie past our heavenly home. In the most recent picture of Copia, the varieties you spot recommend outstanding inner strategies happening inside the article. Even though contrasting it with the mid-infrared instrument photograph, the near-cam photo could appear to be a piece dull at first. However, the differentiation comes directly down to the light frequencies transmitted by the article material. In the near-cam picture, Round openings in white and purple address ionized gas abandoned via the star before then its blast. Researchers accept that cosmic explosion flotsam and jetsam, pushing through, is forming this gas, developing these marginally molded openings and charming potential inside the lower leg. Legitimate corner is known as the huge tan mass. Assumed to be the progeny of the essential cosmic explosion, affectionately known as baby copia, this peculiarity is a light reverberation where far-off soil is warmed by means of the gentle from the memorable star blast, shining as it chills off. The elaborate soil designs and the evident nearness of baby copia to copia, I have charmed research, paying little heed to the apparent closeness. The cosmic explosion remainder is around 170 light, a very long time from its heavenly posterity. The James Webb Space Telescope's new photograph well-known various more modest light reverberation dispersed in the course of, providing an enchanting check out the universe, continuing on to intriguing disclosures. Stargazers, utilizing the James Webb Space Telescope, have recognized another record holder, the smallest earthy-colored overshadow, with a mass just 3 to 4 examples that of Jupiter. Earthy-colored smaller people involve the limit among stars and planets. Going through heavenly arrangement, however, never achieving the fundamental mass expected for hydrogen combination to become stars. Investigating the star bunch IC 348, cycle 1000 m-years away, researchers looked for the smallest earthy-colored smaller people. They tracked down objects with temperatures among 1,150 and 2,800 degrees Fahrenheit and burdens going from 3 to 8 masses. PC models advocate that the lightest of them marginally weigh 3 or 4 occasions Jupiter's mass. This challenges existing styles of well-known individual and earthy-colored bantam development, raising inquiries concerning the beginning of such low-mass heavenly gadgets. The smallest earthy-colored smaller people situated close huge exoplanets offer incredible experiences into exoplanet assessment and proposition hints about the arrangement of stars. Otherworldly still up in the air, earthy-colored midgets look like those of an unclassified hydrocarbon atom situated in Saturn and Titan's airs. The disclosure of such airs in lower-mass youthful objects is amazing and raises inquiries concerning their tendency, whether they're earthy-colored smaller people or rebel planets shot out from planetary frameworks. As the James Webb Space Telescope proceeds with its investigation, it brings uncommon coherence to how we might interpret the universe. The telescope's compelling close-infrared camera permits space's experts to focus on objects with lower hundreds and more youthful ages, testing existing speculations, and extending our data of the universe. The Multiverse Aster channel requests that you remain tuned for additional episodes where we settle the end-span disclosures and disclosures from the significant span of the universe. One of the most intriguing parts of the James Webb Space Telescope is its potential to look into the far-off past. Contribution looks at universes that designed billions of years in the past. This capacity permits space experts to examine the universe's earliest stages, presenting accommodating experiences into the methods that design the universe. The telescope's infrared vision empowers it to slice through vast residue, uncovering designs and peculiarities that have been previously stowed away from view. The revelation of early-stage cosmic systems is especially important. These noteworthy star structures formed in practically no time after the huge explosion give signs about the early universe's circumstances. Through perusing the gentle from these far-off universes, researchers can infer the styles of stars that existed and the components they created. This examination is crucial for understanding the compound development of the universe and the development of the first stars and cosmic systems. Another notable analysis involves the take a gander out of exoplanets, planets that circle stars outside our Sun's close planetary system. The James Webb Space Telescope's progressed contraptions license it to examine the airs of these far-off universes in uncommon detail. By examining the gentle that channels through an exoplanet's environment as it passes before its host enormous name, researchers can go over the presence of various gases and mixtures. This approach, alluded to as travel spectroscopy, has proactively brought about the location of water fume, methane, and other potential biomarkers on a few exoplanets. Quite possibly the most intriguing discoveries is the identification of water fume inside the air of a super-Ear, a sort of exoplanet with a mass bigger than Earth yet more modest than that of Neptune. This revelation proposes that the planet might have circumstances reasonable for presence. The presence of water fume proposes the capacity for fluid water, which is a basic viewpoint for presence as we acknowledge it. These discoveries light the creative mind, raising the open door that presence might exist elsewhere in the universe. In expansion to exoplanetary research, the James Webb Space Telescope has provided wonderful photographs and insights on genius arrangement by checking out regions where stars are conceived, known as heavenly nurseries. The telescope has revealed the complex strategies engaged with star arrangement. Those perceptions have revealed the jobs that attractive fields and turmoil play in the introduction of stars, revealing insight into the complex instruments that oversee heavenly advancement. One of the telescope's most striking pictures catches the Kina cloud, a gigantic haze of gas and residue wherein enormous stars are shaping. The point-by-point perceptions of the cloud, improved by the telescope's infrared abilities, uncover the dynamic connection among gravity, radiation, and attractive fields as they impact the work of heavenly bodies. It may have revealed a portion of the clamps and production of the main stages of our gas time. The James Webb Space Telescope, JWST, represents a monumental achievement in space exploration and astronomy, poised to revolutionize our understanding of the universe across multiple disciplines. From its inception, JWST has been designed to push the boundaries of observational astronomy, leveraging advanced technologies to observe infrared light with unprecedented sensitivity and resolution. This capability enables JWST to explore cosmic phenomena ranging from the formation of the first galaxies to the characterization of exoplanetary atmospheres, offering insights into fundamental questions about the origins and evolution of the cosmos. The concept of JWST originated in the early 1990s as a successor to the Hubble Space Telescope, HST, with a primary focus on infrared observations. Unlike HST, which primarily observes in visible and ultraviolet wavelengths, JWST's design prioritizes infrared wavelengths because they are crucial for studying objects that emit faintly or are obscured by dust, such as distant galaxies, newly forming stars, and planetary systems. NASA, in collaboration with the European Space Agency (ESA) and the Canadian Space Agency (CSA), embarked on the ambitious project to build JWST. The telescope's construction faced numerous technical challenges, including the development of its large segmented mirror, which consists of 18 hexagonal segments that unfold to form a 6.5-meter diameter primary mirror. This segmented mirror design allows JWST to gather more light and achieve higher resolution than previous space telescopes. The construction and testing phase of JWST spanned several years, with multiple delays and budget overruns pushing back its launch date. However, these challenges were ultimately overcome, and JWST's final assembly and testing took place at NASA's Goddard Space Flight Center in Maryland, USA. The telescope underwent rigorous testing to ensure its performance in the harsh conditions of space, including its ability to maintain precise alignment and operate at extremely cold temperatures. JWST's scientific objectives are broad and ambitious, reflecting its capabilities as a next-generation space observatory. One of its primary goals is to study the formation and evolution of galaxies throughout cosmic history. By observing infrared light from distant galaxies, JWST can peer back in time to an era shortly after the Big Bang, when the first galaxies began to form. This epoch, known as the Cosmic Dawn, remains largely unexplored due to the challenges posed by visible and ultraviolet light absorption by intervening cosmic dust. JWST's infrared vision allows it to see through this dust and observe the earliest galaxies, providing insights into their formation mechanisms, star formation rates, and the buildup of cosmic structures over billions of years. Another key scientific objective of JWST is the study of star formation and stellar evolution within our own galaxy and beyond. JWST's ability to observe in infrared wavelengths is particularly advantageous for studying stellar nurseries, regions where stars are born from collapsing clouds of gas and dust. By detecting infrared radiation emitted by these young stars and their surrounding environments, JWST can reveal the complex processes involved in star formation, including the role of magnetic fields, turbulence, and feedback mechanisms that regulate the birth and evolution of stars. Additionally, JWST is equipped to study planetary systems beyond our solar system, known as exoplanets. Through techniques like transit spectroscopy, JWST can analyze the atmospheres of exoplanets as they pass in front of their host stars. This method allows astronomers to detect and characterize gases such as water vapor, methane, and carbon dioxide in exoplanetary atmospheres, providing clues about their composition, climate, and potential habitability. JWST's observations of exoplanets have the potential to identify biosignatures, chemical signatures that could indicate the presence of life on distant worlds, opening new avenues for the search for extraterrestrial life. Technologically, JWST represents a leap forward in space telescope design and capabilities. Its primary mirror, composed of 18 gold-coated beryllium segments, is significantly larger than Hubble's and is optimized for infrared observations. The mirror segments are designed to unfold and deploy once JWST reaches its destination, a stable orbit around the second Lagrange point, L2, approximately 1.5 million kilometers from Earth. This location offers a stable gravitational environment and minimizes interference from Earth's heat and electromagnetic radiation, allowing JWST to achieve its maximum